Good morning. Now we are going to see the first experiment in advanced operating system, that is Lamport logical clock. In a distributed system, it is not possible in practice to synchronize time axis entity within the system. Hence, the entity can use the concept of algorithm clock, logical clock based on the events through which they communicate. If two entities do not exchange any messages, then they probably do not need to share a common clock. Event occurring on those entities are termed as concurrent event. Among the processes on the same clock machine, we can order the event based on the local clock of the system or the logical clock. Now we are going to see the e-record of the logical clock. So our aim is to implement and simulate logical Lamport logical clock algorithm to determine the order of the events in the distributed system. Here the description is: the Lamport logical clock algorithm is used to determine the order of the event in a distributed system. The algorithm provides partial ordering of events which are minimal overhead. If two events occur at two different computers cannot be determined based on the local time at which they occur. They can be determined by the following special cases to order event based on the underlying computation. Happen before relation, causally related events, concurrent events. The condition that is failed by the system The condition is that failed by the system that is satisfying by the system of the clock is general is that for any event if A and B, if A tends to B, then C of A is less than C of B. If condition, that is condition 1, is for any two events A and B in a process Pi, if A occurs before B, then that is clock C is clock, and clock of I of A is less than clock of I of B. And the condition 2 is if A is the event of sending a message is in process Pi, and B for receiving the same message at Pj, then Pi of A is less than Pj of B. So we have certain rules to do this algorithm, that is clock Ci is incremented between any two successive events in a process Pi, that is Ci of is equal to Ci plus D. If A and B are two successive events in Pi and A tends to B, then Ci of B is equal to Ci of A plus D. D will be added to A and it will be given to B. And the rule 2 is if A sends a message M by Pi, M is assigned a timestamp value, that is timestamp is equal to Ci of A. So A value is assigned it as a timestamp value. On receiving the same message M by Pj, Ci is set to a value greater than the equal to present value and greater than timestamp value, that is Cj is equal to max of Cj comma timestamp plus D, where D is greater than 0. So the algorithm contains simple rules, that is a process increments its counter before each event in that process. When a process sends a message, it includes its counter value with the message. On receiving a message, the counter of the recipient is updated, if necessary, to greater its current counter and the timestamp in a received message. The counter is then incremented by 1 before the message is considered received. So the pseudocode for the algorithm sending and receiving is given here. So we are going for the program. So we are for Java we are using import.java.util package, which which includes all library functions. So first we are giving the inputting the number of the process and event. Enter the number of process and events in each process. So through creating an object for scanner, we are using scanner.next input is it will point to the next token of the input, and here arrays for holding the relationship process and the event. We are creating an array list for each input, initializing checked array and creating the initial timestamp values. These for loops are used, and this is scheduling where relation are across process. Scheduling when relations are in the same process, serial or casually related events in the same process, and displaying the final schedule, so which is assigned, and coming to the output, that is first we'll enter the number of process, that is 4, and enter the number of events in each process, so that we are given. Enter the highest number of events, that is 4, and enter the number of relations. So enter the relationship in order, example 1 to 2 and 3 to 1. So enter the process 4. Enter the events 2. 2 is the relation, and enter the process 3. Enter the event 1. So here 3 is the relation to the 1, and it is given here how it is related. So the Lamport logical clock algorithm has been successfully executed. Thank you.